Good morning, students. I welcome you all for this session. Okay, so in the previous class, we have seen how to find out the resultant. Okay, when two forces are acting on a body, that is composition of forces. Now, similarly, before going into the problems, okay, so let us have some discussion on resolution of force. Already we have seen that. So when a single force is acting on a body, that can be resolved into horizontal and vertical. That is, single force can be split into components, that is along x-axis and along y-axis. Yes, so just a small triangle you can see here. Remember, already we have studied in your PUC level. Okay, a small triangle, and this is angle theta, and this is 90 degree. So right angle triangle, and as you know, this is with reference to this triangle, this is adjacent side, this is opposite side, and hypotenuse. Okay, I'll write this as small a. This is side A, B, and C. Now, if I take this sine theta, okay, so sine theta is equal to what? Opposite upon, okay, sine theta is equal to opposite upon hypotenuse. Okay, that is B by C. Then similarly, cos theta is equal to adjacent divided by hypotenuse. Okay, adjacent divided by hypotenuse. So that is A by C. Then tan theta is equal to opposite, okay, divided by adjacent. Already we know that. So remember this. Okay. Then take an example. So if a force is acting, okay, at particular point, so this is an inclined force, and which is making an angle of theta with x-axis. Okay, now how to resolve this force? Okay, resolve means I have to find out component of this inclined force along x direction and along y direction. So from this point, so see, this is the point where this F is acting at an angle of theta. So consider this as x-axis and this is y-axis. So now I have to find out what is the component of this force along x-axis. So resolve this force along x-axis. So if reference to this angle theta, if I take this force along x-axis, then this becomes Fx. Fx is what? Component of this force along x direction. So Fx is equal to F into cos theta. Remember, when an inclined force is resolved along x-axis, if this is angle theta, then Fx is equal to F cos theta. So this Fx is equal to F of cos theta. And when you resolve this force along y-axis, now vertical, and then this becomes F into sine theta. Okay. So if I consider this as the theta, so Fx is equal to F into cos theta, you have to write. Then component in vertical direction, Fy is equal to F into sine theta. Okay. So this thing is important when you are solving the problem. So this you need to remember. Okay. Right. So now let us solve the problems on moment of a force first. Okay. So in the previous classes we have studied moment of a force. What is a moment? Moment is nothing but it is a capacity of a force to rotate the body. So moment is nothing but a rotation of a body with reference to the force. Okay, so for capacity of a force to rotate the body either in clockwise or anti-clockwise direction. So let us solve some problems how to find out the moment of a force first. So find the moment of a force F at A, okay, in the following cases. So there are three different cases. So in that each case you have to find out what is the moment of force. It is given 10 kilonewton. This is the force, okay, and you have to find out moment of this force about point A. Okay, so first, what is the moment of force about A is given by, so moment of this force about A is given by, so MA, capital M is moment and this A is moment about A. Okay, so moment is equal to what? Force into perpendicular distance. Remember, moment is equal to force that is magnitude of force into perpendicular distance between force and where you are calculating. Now where you are calculating moment we are calculating about point A and force is here F. So moment is equal to F into perpendicular distance. Now what is F here? 10 kilonewton. Okay, F is 10 kilonewton. Then what is the perpendicular distance between this force and A? It is 2 meter. Perpendicular distance you have to write. So perpendicular distance between force and point A is 2 meter. So F is 10 and into 2 meter. So force into perpendicular distance. Now see, with reference to A, moment means rotation. Either it is clockwise or anti-clockwise. Now with reference to A, when I move this will going to rotate clockwise. Okay, this force will going to rotate the body in clockwise direction. So clockwise means it is plus. So moment is equal to plus 10 into 2. 10 is force, perpendicular distance between force and point A is 2 meter. So plus 20 kilonewton meter. So that is equal to plus 20 kilonewton meter. So plus means it is clockwise rotation. Remember. So plus means it is clockwise rotation. Minus means it is anti-clockwise rotation. Right. So this is first case. Second case, same force. F is now 1000 Newton and point A is here. Okay, and this is a perpendicular distance. Is it right? So perpendicular distance between this force and A is 2 meter. Now what is the moment of this force about A now? Okay, again force into perpendicular distance. So force is 1000 Newton. Perpendicular distance between this force and A is 2 meter. Okay, now with reference to A, okay, with reference to A, you have to note down whether this is clockwise or anti-clockwise. See, with reference to A, this will going to rotate anti-clockwise. So anti-clockwise means minus. First you have to write down plus or minus depending upon the rotation. If it is rotating clockwise, write plus. If it is rotating anti-clockwise, minus. Now with reference to A, this will going to rotate anti-clockwise. It is minus. Force is 1000 minus 1000 into perpendicular distance between this force and A is 2 meter. So 1000 into 2, that is minus 2000 Newton meter. So answer is not minus. This minus indicates it is anti-clockwise. So remove the minus sign. So moment at A is equal to, remove the minus sign, write down 2000 Newton meter. So this minus is because of anti-clockwise. It is anti-clockwise rotation. So remove minus sign, show it is anti-clockwise. Right. So this is moment about A. Now third, same force, that is moment of this force which is 20 kilonewton. Now the point A is here now. Point A is here. Now in this case, see that. So for this force and point A, what is the perpendicular distance? This is the perpendicular distance. But it is not given. It is not given. This is given. So I cannot write moment at A is equal to F into 2 meter. No. It is not a perpendicular distance. So perpendicular distance between force and A is this L. So L is not given. We have to find out L. So see, this angle is given. This angle is given. So right. So in this problem, perpendicular distance from A to the line of action of this force is not given. But I can calculate this perpendicular distance. So if I take this in this triangle, if I take sine 30. So sine 30 is equal to what? Opposite, that is L divided by this. Okay, hypotenuse. So sine 30 is equal to opposite divided by, because this is given now. Okay, we have to find out this. So sine theta you have to take. Sine theta is equal to this opposite L divided by 2 meter. So that is L by 2. So what we want? We want L. So L is equal to 2 into sine 30. Okay. So L will get 1 meter. So means perpendicular distance between this force and A, this perpendicular distance is 1 meter. Now you can calculate moment of this force about A. So that is MA is equal to force into perpendicular distance. So force is 20 kilonewton, perpendicular distance 1 meter. And with reference to A, this force will going to produce Okay, anti-clockwise movement. So it is minus. So minus 20 into 1 meter, perpendicular distance 1 meter. So that is minus 20 kilonewton meter. So remove the minus sign. So MA, moment about A, is equal to 20 kilonewton meter. So force is kilonewton, distance is meter. So it is unit is kilonewton meter, and this minus sign indicates it is anti-clockwise rotation. So remove the minus sign, show this is anti-clockwise rotation. So like this, so whenever you are calculating moment, right, so force is required and perpendicular distance you have to write down between the force and where you are calculating the moment. Okay, next, so one more problem we are going to take. Find the moment of 500 Newton force. Now see, find the moment of 500 Newton force about the points A, B, C and D. So at these points you have to find out moment of this 500, that is MA, MB, MC and MD. Okay, now see, observe here, this 500 Newton force is acting inclined at an angle of 30 degree. Now see, at an angle of 30 degree with, now this is, you can take this as a x-axis now. So here onwards, remember, whenever a force acting inclined to a particular point, and if the angle is given, you have to resolve that force into x and y direction. So along x and y direction. Now see, this 500 Newton force making an angle of 30 degree with this horizontal. So yes, I can resolve this force along x direction and along y direction. So instead of inclined force, you can take, because if I consider only this inclined force, then I cannot calculate the perpendicular distance between points and this inclined force. So that's what you have to resolve that force along x direction and y direction. So when I resolve this x direction, see, when I make this horizontal, this will go in this direction. See, it will go in this direction. So 500, this angle means 500 cos 30. Okay, 500 cos 30 in this direction. See, 500 cos 30. Resolve this vertical now. Make this force vertical. Right? If you are taken, this is 500 cos 30, then vertical will be 500 sin 30. Okay, so vertical will be 500 sin 30, horizontal will be 500 cos 30. Now instead of this figure, now you can refer this figure. So there are two forces now. Instead of this single inclined force, there are two forces. So one is 500 sin 30 vertical and 500 cos 30 horizontal. Now what moment of these two forces I have to calculate about A, B, C and D. Now first, moment about A. So moment of these two forces about A. Okay, so that is MA. So MA is equal to, you have to take one by one force. First I will take this. Okay, 500 sin 30. So force is 500 sin 30, and what is the perpendicular distance between this 500 sin 30 and point A is, now see, this is the line of action of this force. Okay, and what is the, where is the point A, and what is the perpendicular distance between this force and A is 6 meters. So force is 500 sin 30 and perpendicular distance is 6 meters. Now see, 500 sin 30, perpendicular distance between A and this is 6 meters. Okay, and with reference to A, this will going to produce clockwise. So plus 500 sin 30 into 6. And what is the moment of this force about A now? There are two forces now. One you have taken. Then second is this. So force is 500 cos 30. And what is the perpendicular distance between A and this force? 0. See, this is passing through A. Is it right? This is passing through A. So there is no perpendicular distance. So perpendicular distance is 0. So 500 cos 30 into distance is 0, means this is 0 only. So since it is passing through point A only, there is no moment of this force. So there is only moment of 500 sin 30 into 6 meter. So plus 500 sine 30 into 6 plus this moment will be 0. So it is 1500 Newton meter. So this is plus means clockwise. It is clockwise. Right. Next, same forces about B now. This is a point B. Moment about B, MB. Okay. Again take one by one force. First this. So 500 sine 30 is the force, and where is the point B, and what is the perpendicular distance between this force and B? Now see, this is the force and this is point B. What is the perpendicular distance between this B and this force? Again 6. So with reference to B, this will going to produce clockwise. So 500 sine 30 into 6 meter plus 500 sine 30 into 6. Now this force now. So what is the moment of this force about B now? Right? So again force into perpendicular distance. So force is 500 cos 30 and perpendicular distance between. Now see, go on this. Okay, this is the force. And what is the perpendicular distance between this force and B? It is 2 meter now. Okay, it is 2 meter. So with reference to B, this will going to produce anti-clockwise. So minus. So this is plus. This is minus. So minus 500 cos 30, okay, minus 500 cos 30 into 2. Why it is 2? So this is the force and this is point B. This is perpendicular distance is 2 meter. So answer will going to get plus 500 sine 30 into 6 minus 500 cos 30 into 2. So this answer will get plus 633.97 Newton meter. Now force is in Newton. See, distances are in meters. So unit is Newton meter. So plus means clockwise you have to show. Okay. So this is point B. Moment about point. Now moment about C now. So moment of these two forces about C. So moment about C, MC is equal to again 1 by 1 force. First this force. So what is the moment of this force about C now? Okay, now this is the force. Okay, move on that force. This is the force, and where is the point C? Here. What is the perpendicular distance? This is 6 meter. So with reference to C, this will going to produce clockwise. So plus 500 sine 30 into 6 meter. Perpendicular distance between this force and C is 6 meter. So plus 500 sine 30 into 6 and this force. Okay, force is like this and perpendicular distance between this force and C is 3 meter. Okay, this is the force, line of action of force, and point C is this. So it is 3 meter. So moment of this force is, now with reference to C, this is anti-clockwise. This is anti-clockwise. It is minus. So minus 500 cos 30 minus 500 cos 30 into 3. Minus 500 cos 30 into 3. So this is plus, this is minus. Again you will going to get plus 200.96 Newton meter. Moment about C is equal to 200.96 Newton meter. So plus means it is clockwise rotation you have to show. Moment means it is a clockwise rotation. Now next, moment about D now. Moment of these two forces about D. Again take 1 by 1 force. Now what is the first, I will take this force. What is the moment of this force about D? Now see, if I extend this force, this will going to pass through D. Okay, when force is passing through that particular point, then moment of that will be 0 because there is no perpendicular distance between this force and D. So moment of this will be 0. Now consider moment of this force. What is the moment of this force about D now? Right, with reference to D, this will going to produce anti-clockwise. Okay, so anti-clockwise means minus. So minus, this is the force, minus 500 cos 30 into perpendicular distance between this force and D is 3 meter. Okay, so minus 500 cos 30 into perpendicular distance between this force and this D is 3 meters. So minus 500 cos 30 into D, that is 3, and moment of this is 0 because it is passing through D only. So only this much, it is minus now. So minus 1299 Newton meter. Okay, so remove the minus sign. So write 1299 minus means anti-clockwise rotation. Okay, so like this you have to calculate. So whenever the inclined force acting, so make that horizontal and vertical component forces. So horizontal will be cos theta, vertical will be sin theta. Then the moment is equal to what? You have to force into perpendicular distance. So if it is clockwise, you have to write plus. If it is anti-clockwise, you have to write minus. So remove the minus sign, show the rotation it as anti-clockwise. So these are the small problems. Remember once again, solve these problems. If any doubts, right, so can feel free to ask. Okay, so in the next class we'll solve some more interesting problems, how to calculate the moment of force. Okay, so hope you understood this, and thank you very much for attending this session. Okay, so in the next session we'll come up with the some more problems. Thank you very much.